we'll be hearing about the use of open source for marine data ingestion and discovery. So, floor's yours.
Thank you. So, so we've been building this system for a few years now, since 2023. Who are we though? The Integrated Marine Observing System was created about 10 years ago because oceans are very important to Australia, but historically we were actually very uncoordinated about the data. Individual universities and organisations were measuring the data themselves, and there was no real central place for people to come and get that ocean data. So IMOS was created to coordinate this data observation and providing it to the users across Australia, across those various organisations, the many universities, the CSIRO, the Bureau of Meteorology and whatnot. And so this is the sort of selection of data that we actually manage ourselves in collaboration with all of these other organisations. It's a very variable set of data you can see. We've got animals that are tagged and are floating around, swimming around in the ocean. We've got satellites going up in the air and measuring raster data, all sorts of different things that we have to manage. And then beyond that, I work for the Australian Ocean Data Network down the bottom there. So our job is to not just manage IMOS data, but all of the any ocean data that's related to Australia at all. We try to bring it into a central location, make it available and discoverable to the people who need that data. We've had a portal for a very long time whose goal was to provide this use case of allowing researchers to discover what ocean data is available and then access it. But we did a review and we found various problems. One is that it was difficult to actually find data using the portal. The portal was designed 10 years ago. It just didn't provide people with good enough search capabilities to actually find the data that they were intending to find. It was hard to use when it was built. We didn't have any UI designers, so it was just sort of designed by developers, and it was using a very, very old UI framework. So we decided to overhaul those things, bring on a UI designer to actually design properly. We also found we had a catalogue of 14,000 data sets of ocean data from around Australia, but actually on the portal only about 150-ish were available. And that was because the way we designed it was evidently too difficult for the providers to actually give us the data sets. Sometimes a provider might have a policy reason that they need to provide us with a data set just to show that they're contributing to the AODN, but then they would only do the one data set because it was too hard and they wouldn't do any more. Data extraction was slow and costly because we were working on non-cloud optimized data. We were having to do in the background when people were subsetting and downloading their data. Things just weren't going fast, so we decided to move to cloud optimized formats. And also data ingestion was very slow and hard to maintain because of the system that we were using, which was just this historical sort of bad decision making and sort of old technology that we were using. It's just causing the data engineers all sorts of headaches. So we decided to move to a much nicer Python-based orchestration framework. So, like I was saying before, okay, it had 300, this slide says 300 data sets, but in our overall catalogue we had over 14,000 data sets. So we really wanted to enable people to find this huge host of ocean data that's available in Australia beyond what IMOS provides. You can see that blue circle. We did have a little bit of data from other people outside of IMOS, but not really enough, and we wanted to make this all very available. We also have funding, have gained extra funding to actually expand our own little bubble there, which goes into again with making it faster to create ingestion pipelines. So this is what we've sort of designed. I'll walk you through it maybe from the right-hand side. You can see that we start with files that are in NetCDF format. This is a very popular format in the ocean data world. For our own data providers, we sort of enforce this, and we have our own standards to make sure that they follow that. It's sort of very multi-dimensional, it's very customizable, it allows basically any sort of data can go into NetCDF, which is ideal for us because we're receiving so many different types of data. We then use an open source framework called Prefect to orchestrate the pipelines, the flows that they call pipelines flows, which allows us to convert these NetCDFs into cloud optimized formats, which we use Parquet for tabular data and vector data, and we use Zarr for our raster data. And you can see here that our intention is for data scientists to just be able to access that cloud optimized formats directly using, and we have Jupyter Notebooks. We've made Jupyter Notebooks available for them to work out how they can actually access that data. But for developers, often they like APIs, they like standards, so we're also making sure to implement the OGC APIs which will, in the background, will be using the cloud optimized formats, but we are making these OGC APIs to do things in a standardized manner. And right now we're keeping that internal, but the plan is to eventually make it external, but we want to make sure we get it stable before making that public. You'll see here above that OGC APIs is also Elasticsearch. So Elasticsearch is a pretty great open source tool for storing large amounts of data, making it searchable. And that's actually, the reason we've got that is we have this catalog, which is a historical thing. We've got GeoNetwork running that catalog of 14,000 data sets. We want to index them and make them easily searchable. And Elasticsearch does a great job of that. And for the general public, obviously they don't like to use APIs, they don't like to use Python or R, they like to just use a website. So we've built our data discovery front end using the React framework, which accesses the OGC APIs directly. As far as indexing the metadata into Elasticsearch, we are hosting our Elasticsearch on Elastic Cloud, who is the organization that actually creates Elasticsearch, and we've been very happy with them. It allows lots of sophisticated retrieval functionality. It also allows some mapping functionality. They've got a lot of extra little bells and whistles in Elasticsearch, which we've really been happy with. We did make a choice between OpenSearch and Elasticsearch and went with Elasticsearch because of all this extra functionality that they provide. We augment our metadata using an LLM, and we also augment it using data to provide for this mapping, these mapping capabilities. So OGC APIs, which are the modern Open Geospatial Consortium's API standards, we're using tiles, processes, records, features, stack. We might be using others because basically we can just pick and choose, right? That's the new way of doing things in OGC, and it's very fantastic. Our developers have been very happy to just pick up the standard, see what they can do with it, and then implement it themselves. We implement in SpringBoot. So therefore, from SpringBoot, we can then call off to any other application we have in the background, off to the cloud optimized files, off to Elasticsearch, and just provide all the functionality in a standardized manner using these various things. Currently internally only though. Challenges with what I've just been talking about. Firstly, we are AI augmenting these data sets, and most of these data sets are not ours. I mean, even when it is ours, we're still kind of worried because AI can do all sorts of crazy things. So we have to make sure that we're letting our users know that we are augmenting these records. We also have to be careful to make sure we do quality assurance on this AI augmentation, make sure it's not giving any false data, especially from a reputation perspective. It would be very bad if we were giving people bad data, bad information. But mostly we've tried to, firstly we've done a lot of testing, and secondly we've ensured that the AI is being asked to do very simple, obvious tasks. For instance, changing the formatting. With all these 14,000 records, there's a lot of records that are really badly formatted. They might not have paragraph breaks, they might not do proper linkages to other websites. So we just want to make that all sort of normalized so that they all seem like they're visually the same, looking correct. And that's an easy thing, hopefully, for AI to do, which is what our testing suggests is correct, that AI can do that okay. Quality assurance of dataset functionality is also important because we're providing for sort of visualization functionality on this portal, and we're going to be doing more visualization functionality in the future. Right now we're just doing maps, but our plan is to do like time series and maybe some depth profiles and other things that we can do with our various types of data. But because we've got this large number of data sets and we sort of want to automate this functionality based on the data, we do have to be careful that we're not automating in a way that misrepresents other people's data. So that's a challenge that we're currently facing, where we're having to work out how we can actually quality assure for that many data sets and make sure that our portal isn't doing something that's going to get us in trouble with someone else who doesn't like their data being visualized in a manner that's misleading. And then we've also dealt with the question of how to visualize large numbers of data sets on one map. We sort of want to visualize, make it searchable. Does that not work? Should have checked this out. Oh, that works. Thank you. Yeah, so I'll give you a bit of a demo of the functionality of our portal. So you can see here, it's pretty basic at the start. We can choose a set of facets at the bottom. We can also do a time search. We only want data from a particular time range, last 5 years, last 10 years. We can do a location sort of test of, in Australia, for ocean data, marine parks are important. And then we've got various other selection options that we might find interesting. So I'll just choose IMOS there, do a search. And so you can see over here on the right, we're trying to visualize where basically the data sets are. Now, some data sets are very expansive. They cross a lot of the ocean, but we're just trying to give people some sort of idea when they sort of zoom in how much data is available. Let me just change from here. Yeah, so we can see that so we can see that people who are interested in a particular area get a good idea of what's actually available in that area. We've tried a few different ways of visualizing this. We've also got this, so showing more sort of points and a heat map. And if I go into a result here, like for instance, underwater, is that not there? What was I searching for then? Oh, right, temperature. So if I go into here, we can see this is coming directly from the metadata record with some AI augmentation. We have a little AI button here that informs people this has been AI augmented to improve the layout, so it shouldn't have any actual changes to what's being said. We can see here on the map, we're visualizing the trajectory of this, what is it? It's a ship of opportunity. So this is a ship that's not owned by us, but they've allowed us to put sensors on it, and then as they go on their trip, we get the sensor measurements back from them. So all the different stuff that's available from a standardized metadata record is available here. People can go and understand the data that they want. A lot of this, and we would see if something's been AI augmented, we would yet again see a button, and then we can download the data over here. So we take someone's email address, do a little survey of them. They get this is very important to a lot of data providers, they get information about how the data needs to be cited, and then they click the button and it goes to download. So what's going to happen now is I'm going to get an email telling me that the download was started, and then later on I'll get an email, probably in 10 minutes, an email saying, okay, your download's there, it's going to be sitting in S3 for me. So what's happening in the background there with that download? So in the background, we've got cloud optimized data, Zarr and Parquet. The idea of cloud optimized data is we don't make users download data. Instead, we design data formats to work over the network and provide code libraries to enable direct access. So Zarr and Parquet make it very efficient to access directly. And that's what we're providing to data scientists. And that's what we can use in the background of our portal as well to actually provide this data download to the users who don't want to be using coding. They can still download their subset. We can manage that quickly and efficiently. And in fact, we're putting it onto the AWS Open Data Program. So AWS kindly give us this data for free, give us the data storage for free. They pay for all of our data storage for our cloud optimized data on the Open Data Program. And I can show you, oh nice, what that looks like. Here's their Open Data Program. We can do a search for AODN and find lots of AODN data that's accessible. It gives a little spiel about what the data's for and gives us access to the catalog description and some usage examples. So we can go to a Jupyter Notebook and understand this data set. Where is the data available? We can see this is actually going through step by step how a data scientist could use this specific data set, various things they can do to graph it that might be useful for that particular data set. Here's a time series, I assume it is. Some temperature locations, although the temperature doesn't seem to change very much. Yeah, just lots of, and then some stuff that I don't understand. So yeah, lots of different, anything that our data engineers think, okay, that's going to be useful. They sort of display to users how they can do it in this Jupyter Notebook. Sorry, I don't know how to just go from a slide. So what are the challenges we faced with this cloud optimized? Firstly, updating cloud optimized is not super easy. They're not really made that way. If you want to change the partitioning strategy, you want to change what variables you actually have available, you have to go back and sort of recreate the whole thing from scratch, it seems. There are two formats, Iceberg for Parquet and there's other things for Parquet, and also IceChunk is in development for Zarr. We haven't used them, but they do seem very good because they sort of allow you to abstract away that partitioning and stuff away from the user, have a higher level, and allow you to make those changes under the hood without the user noticing. This is also important to us, not just for partitioning, but because our data does get changed. It goes through a lot of steps before it gets to us, so there's a lot of places where the quality can go wrong. You know, they've got the sensor, and then the sensor goes to the facility then has to convert that sensor data into less raw data, and that then have to convert that to NetCDF in our format, which can be passed on to us. We then have to convert that format to cloud optimized. There's a lot of steps in that process that can go wrong, and so sometimes data will be updated. Partitioning strategies, we also have to think about what partitioning strategies do we need for the access of our users. So that's going to be a matter of monitoring how are people using our data and understanding, okay, for this particular data set, what partitioning strategies do they need to make their life easier. And web time access of cloud optimized data especially has been very challenging. It takes, we've noticed that if we partition exactly right, we can get very, very fast requests for the things we want, like creating time series, under a second. But as far as whether you can, we're actually having to, but to do that, you actually have to recreate the file. So questions around whether we can actually use this for something like creating a time series on the front end, or whether we should just index into Elasticsearch for that and create the time series from Elasticsearch. For ingestion, we're using Prefect orchestration library. It's awesome. It's pure Python. It's lightweight. It's container-based. And it gives us our data engineers really good visibility for troubleshooting. Basically, to make it work, they simply put what do they call annotations on their Python that defines what's happening, that defines what's going to be visualized, and defines what Docker containers are going to be run up and what code is going to be run in them when they want to do their orchestration. So I'll show you here. It's running. Our Prefect can sort of do the cloud optimization flows, create Parquets and Zarrs. It can ingest the documents, the files that we get from other people. It can do some indexing of stack catalog and Elasticsearch. It's really working well for that. And I'll give you a diagram of basically what our ingestion flow looks like as a whole. So the contributor comes along and they pop a file into our landing bucket or into FTP. Or we might pull from someone else's API that gets ingested, put it into a source bucket archive, into a data bucket, and then we can run lots of other flows. So it sort of allows us to, instead of having one big long pipeline that's all defined in one thing, this is actually lots of little pipelines that react to whatever's happening in the underlying system. Thank you. So our portal can be accessed at portal-beta.aodn.org.au. Our notebooks are available at this GitHub repository, and you can contact me at this email address.
Excellent. Thank you. Thank you, Alex. We have time for one or two questions, and Meredith, I can.
Yeah, thanks. I'd like to buy one of these. You said it took a couple of years. Could you give a vague indication how many people and how many millions?
How many millions? I don't know. Oh yeah, so I would say for people, we have a team of probably 8 software engineers, and then, yeah.
So that's like multi-million-dollar, multi-year project.
It would have been, yeah, if you add up all their salaries, yeah. And that wasn't including the data engineers either, yeah. So.
Yeah, I want one though. He's nice.
Yeah, another question. Last question.
Thanks, that looked really cool. I interacted with the old version of the portal, so drastic improvements. When you chose Elasticsearch over OpenSearch, you mentioned there were extra bells and whistles. What were they?
Yeah, so basically, when we go to the map section and we're mapping those search results, all of that's actually coming from Elasticsearch. Elasticsearch actually provides the vector tiles to do that underlying thing, and that wasn't available in OpenSearch. I'm also pretty excited about Elasticsearch has released a serverless version now. It's not available in Australia yet, but like that means you just completely don't have to worry about servers at all. That's very Amazon's OpenSearch serverless isn't actually serverless. They just named it that as a bit of an advertising gimmick. But Elasticsearch has made an actual serverless version, so that's awesome when it comes to Australia.
That's a service or
As a service, yeah. I don't know
service.
that it would be probably not runnable by yourself, yeah. Elastic Cloud, yeah.
All right. Thank you very much. Thanks, Alex. Have a 5 minutes changeover.